In this block, I want to talk about abstraction and the way that is reflected in some of the standard type classes of Haskell. If you remember, we talked about abstraction as a question of spotting a pattern, maybe in some data or maybe in a computation, and representing it directly as an object, as something in the language, an artifact in the language. And we talked about the spotting the pattern of mapping along a list, taking a function and applying that function f to every element of the list. And we also saw the idea of folding, taking a function which combined all the elements of a list. And we saw that that embodied primitive recursion, so we could define all sorts of things by means of that fold. But if we just look back to mapping, we're saying map f to every element of the list. But you could just think, well, map could be just apply f to every element in the data structure. And maybe we can think of mapping across data structures other than lists. In a similar way, we could think of combining all the elements in a data structure using a function, using an operator. So can we think of types that might be mappable, types that might be foldable? And the way that we do that is by representing that in a type class. And that's what we're going to do in the next few segments. We're going to look at some type class of functor and applicative, and then we'll move on to monad, which is really where all this discussion came in, how we represent computation inside our Haskell type system. Okay, let's get started.